This is W1AKN. I'm here with N1HOQ and W1PJM. We're setting up a remote portable satellite tracking station. I'll get out of the picture here. We'll show you how we set up the external components here, which would be the antenna system. Of course, it's necessary to run feed line. As you can see here, W1PJM and N1HOQ are laying out the feed line into the internal temporary shack we set up inside the school. This is an effort, a dry run that will precede a session where we attempt communication with the International Space Station. This dry run is to establish the procedures and the configuration will be required for the actual session later on this week.
You want to pull that side more?
Well, basically what we have is, let me pan over here, hope I'm not making anybody too dizzy. What we have is the tripod over here right now, mast and the antenna. They'll all be set up. There's N1HOQ, and he's going to make sure that the feed line is correct here at the antenna location. And then what we have left okay. We've changed batteries and we've returned to the scene. Let's see what we got going over here. We got Sean laying the feed line into the internal shack in the school itself. And we have Paul over here at the antenna. We're gonna lay some. We'll get finished with this feed cable. We'll be finished with the feed cable and we'll return back to pick up the antenna setup.
Friday, I'm going to have
All right, now we're going to it's kind of fun. We'll relocate this so that we can shoot this whole thing undisturbed Okay.
You're gonna have to help me pick up. I got my shoulders off. All that luggage at work. The shoulders all screwed up. If I go up so high, my arm is locked. Right. Do I go on the other side of the fence? Hand it off there. Yep, just gotta lift it up and over the thing. Got it. Started to fly.
Okay.
Now, well, we gotta board that thing first. And we'll leave north that way. I think I've still got my compass. I got a compass on my phone, Sean. Do you? Okay. It should be that way. We'll just have to flip this around 180 degrees.
What are we looking for?
So you're trying to get your antenna? Yep. Basically point right at that chimney.
We can get the antenna pointed north so that we'll have a reference in order to set azimuth later on. Elevation's not a problem, but azimuth we need to get the antenna pointed north as our beginning point of reference. Alright, let's make up our cables, connections for this end. Sean and Paul make sure that you have the proper cable ends.
Not a problem. Just gotta swap ends.
Oh, I'm sorry, I saw that in there. I was wondering why they were two different. Alright, now we make up the cable ends.
There. We got our control cables connected, so we have some rotator. And now we start putting together the shack inside. You got one of these without knots in it? Nope. They all got knots? No, they don't, but that's the only one I got like that.
There we got W1 PJM preparing the egg beater onto the mast. We'll put that on the tripod, and that will pretty much take care of the antenna end of the business. Alright, as you can see, we've got the egg beater, and we have the satellite antennas configured, in place, feed lines and what have you connected. We'll pick up on the inside when we go to complete the shack inside. All right, what we're looking at now, folks, is M1HOQ and W1 PJM are setting up the shack, the temporary radio shack inside. We've seen the antennas erected, the feed lines and control cables run, and now the arduous task of constructing the temporary radio shack. So let me get out of the scene. We can watch these gentlemen do their job, which will be hooking up an ICOM 910H to a 1452G linear amplifier. The control cables and feed lines connected. Paul's hooking up the linear amplifier to the power supply right now. And as you can see, the heart of the whole system is the ICOM 910H and the computer, the PC that you see, the notebook, over there by Paul's shoulder. All right, let me pause this for a bit. We'll let them get a little more caught up and then we'll resume shooting. Here we go, we're back to record. And HOQ is finalizing some of the setup of the temporary ham station. And this, I'm assuming, will go right over here. Is that
wherever is we can get it on there. Otherwise, I may have to use another clamp and a piece of board to make that work. We'll do what we can. Look here. This is motor control, goes to the USB. Rig control. 910H. What's in there? Slips into another. USB.
That feels fairly good. Let's see what we're supporting here. That's not too bad. All right. Now tile and crust.
What we try to do is get them set like this.
Yeah.
So that the weight is down, not pushing against. So let's see if we can get this one here.
Oh, yeah, it's a smaller area here.
Say if I have to, I can take a little piece of
Well, we got a smaller here. Do you careful? Are you sure? How's that?
I have to, I can always drill a screw. Not concerned about this tape. The extra fancy golden EIB microphone with us here today. And we'll have the backup icon and mic just in case.
All right, as you can see, we've got the power supply, linear amplifier, the 910H, and external DSP unit all set up on the table. We've got the Heel Gold Line microphone and boom, and the backup hand mic, should we need to resort to that. There's a little close-up. There's your power supply, linear amplifier, and there's the 910H and the respective DSP unit. All right. We'll break away for a moment, and then we'll get back when we get to test the initial setup. All right, folks, we're back. And N1HOQ is now going to go through the testing procedures to make sure that all of the equipment is online and fully functional. Meanwhile, the foreman, W1 PJM, is making sure he doesn't do anything wrong. I'm sorry, this is W1 AKM, the wise guy. Let me zoom in, see if we can take a peek over Sean's shoulder. As you can see, he's looking at the relative positions of the satellites on the computer.
RK repeater.
And now he is warming up the transceiver.
N1HOQ portable testing.
What a portable. What a portable.
Yeah.
Yes, portable doesn't necessarily mean HT, ladies and gentlemen.
N1HOQ clear.
Nice sound. I like that big speaker. I have a pair of those in my...
Copyright that in the station.
Yeah, I have a pair at home and not doing anything.
Well, that's what I did at the 2000. I set up two nice, really good speakers, like that quality speakers. It's like big bass sound.
Yeah.
I can see the antennas.
What's the matter?
I can almost see that thing turning the antennas.
That's what you want to do, is get a video of the antennas tracking.
Yeah, let me know when you're going to cycle them. You're going to calibrate?
Actually, you know what? Maybe we could move that platform back so I can see it from here. Because I would really...
Let's go to standby, folks. We're going to reposition the antennas. We are back, ladies and gentlemen.
I am just put the controller cables together for the azimuth and elevation rotator. And we're going to test the systems here using the local repeaters on 2 meters to make sure everything's working well. Then we'll test the rotator system, make sure the elevation and azimuth is working correctly. We are aligned here so we can look right out the door, out into the baseball field where the antenna system is, so we can verify the operation. So that's where we are right now. Over here for equipment we have, it's a little bit different than what we did for moon bounce, EME demonstration. This is the satellite station that I use for field days. And this rig is the ICOM 910H. It's capable of 75 watts out on 435 and 100 watts out on 2 meters. Today I'm using also the outboard TimeWave DSP 599ZX, and we will be taking the line level out of here on the actual ISS contact event day and sending that to a PA system so that everyone in the room can hear clearly the astronauts when on the downlink. Of course, the computer for tracking control, satellite tracking control. We'll also be tracking ISS with this, of course, on next Friday, the 26th of October. This program will control Doppler on the radio, Doppler shift, and will also control the Yaesu azimuth elevation rotator. So we'll be under complete computer control here. And on this side over here, you might notice a familiar TE Systems 1452G amplifier. We have that mainly for the preamplifier that's in line there, the gas-fed preamplifier. It will also allow us to put about 100 watts out without any trouble at all. We do have a little bit more coaxial cable than we would normally use here but we won't have any trouble with the preamplifier and the amplifier. So that's it. So we've been testing on a few of the local repeaters. We'll test on 955, which is the, I think they call that the Dennis machine now.
Why don't you explain the Yaesu rotors?
Oh, the Yaesu rotors? Sure. This is the controller, and we have elevation over here we can operate manually, and azimuth, which we can control left and right here if we wanted to. But the computer will be taking control of that unit today. And that allows the antennas to rise and lower to track the satellite. Also your azimuthal control to keep it trained on the satellite. So. But that's it. The antennas outside are circular polarized satellite antennas made by Gulf Alpha. And they're on a small platform, and we'll be looking at those in just a bit. So we'll test again on the local repeater, see how we're doing. We're pointed generally north, so we'll see how we're doing with some of these. And 1HOQ testing. This sounds like we're doing fine into Dennis, with the antennas pointed away. This is Sandwich. And 1HOQ test. And it would seem we're getting in there just fine. And this is Falmouth. And of course we're getting in here. We can get into Falmouth repeater with milliwatts. And 1HOQ test and clear. There's the Falmouth 2 375 N1YHS, I think, repeater.
N1YHS repeater, Falmouth, Massachusetts, PL 110.9.
NYHOQ test and clear.
Good morning, Ralph.
What's up next here? That's Vineyard, I think, or Nantucket. We probably won't get that. No, that's Nantucket, so we need to be pointing that way. 27, 345. Not sure what that one is. There's Dartmouth. We need to be pointing there. Fairhaven. That's Fairhaven repeater. And we're getting into that just fine. There's that 685 repeater. We won't try that one. And the rest are a little bit further away. So it looks like we're doing okay on 2 meters. For this event, our primary focus is on 2 meters.
W1ICU.
For this event, we will be using 2 meters primary. The 435 antennas and equipment and capabilities will only be used for satellite demonstration today. But we won't be using those on Friday for the ISS contact because those frequencies, both of the uplink and downlink, are on 2 meters, so we won't need the 435 equipment. But we will be testing it today with the satellite passes that we're going to try to hit. So the 2 meters seems to be working well, so I'm satisfied that we'll be okay with that. I think we'll do a little test with the amplifier and see how that works with the preamplifier next.
Portable listening.
Another portable out there. Well, the preamp is certainly working well. It takes a S7 signal from the Fairhaven repeater and looks like about 40 over with the preamp in, so that's working well. Okay. what kind of power we're drawing. We've got the exciter at as low as it will go. Let's see what we've got with the amplifier in. Looks like about 38 amps, 12 volts. And I don't see any smoke coming from the antenna outside, so I think we're in good shape. So it's close to, it's about 175 watts, I would estimate, output with the ICOM 910H at its minimum power setting for excitement of the linear. So, I think we're in good shape here, RF-wise, in the shack, in our portable shack here at the school at East Falmouth. And I think it's time we give a shakedown to the azimuth and elevation controller next.
Super. Excuse me a moment, Sean. I'm going to relocate the camera. All right, Sean's going to take them through a dry run. Paul's going to maintain a watch on the equipment to make sure that there aren't any binds or glitches. And as you can see, elevation is being tested at this point in time. And now we do azimuth to, and this is basically how you would track the object up there in low Earth orbit. These would be LEO satellites. And now as we see, lowers the elevation and continues to correct azimuth, follows the object from one point in the sky for the approach, and all the way over to the horizon at 0 elevation. There we go. And now he's going to hit the photographer with a couple of thousand watts. No. You're continuing to check elevation. You need to make sure that you've got full sweep. None of your cables are binding. And that the elements of the antenna system have free reign. Beautiful. And as you can see, now it would be a direct overhead. It would begin to come around with the elevation, the azimuth. Elevation is at maximum. And once it gets where the object will descend, you'll see him begin to bring down the elevation. And now track the descent of the satellite eventually to horizon. These are the Gulf Alpha satellites. The longer elements are 2 meter. The ones with the smaller elements would be the 440. Basically, for the FM repeater, they have an uplink and downlink, and they need the 2 meter band for down, 440 for up. And that would conclude the antenna testing. Let me relocate back at the shack. Alright, well now we're going to get ready. We've moved back into the shack, temporary shack. We're going to get ready to test with an actual satellite. Just to give you a quick idea, this will be the audience. Later on in the week, we'll sit out here. And Sean will take one student at a time and allow them to address the commander. of the International Space Station. All right.
We've got 2 satellites up now. We have VO52 we're going to listen to, also Oscar 7 is up. So we're going to go ahead right to our automated control, our CAT control of the radio and rotator control. So I'm just going to click on, we're going to go ahead and take a listen for VO52. Okay, I know, I have to restart the software here, because I have to do that when I plug these things in. So, just give me a moment. Let me restart.
Now, what software are you using, Sean? Did you want to mention the name on that?
Yeah,
or?
this is SAT PC 32.
And that's available out at the...
Yeah, it's available right from the AMSAT website at amsat.org. All the proceeds from the author of this, Eric Eichmann is the author, and all the proceeds from the sales go right to AMSAT for the construction of new satellites and their programs. So, okay, here.
QSL, that is November 9th, you're off your X-ray in Echo November 5-2. QSL? Okay, yeah, I got it, sorry, but you got a little soft there for a little bit when you're
Got
giving your
excellent
call
signals
back.
on VO52.
Name here is Dean.
This is a sideband bird.
November, Dean.
In other words, a transponder satellite.
New Britain, Connecticut. QSL?
Signals are excellent.
Romeo, Yankee, Alpha, November. I'm just trying to find myself here in the upward. Give me just a second. Here I am. Ryan, Romeo, Yankee, Alpha, November. Go ahead.
Again, the antennas are tracking the satellite automatically now via the software and computer.
I just tuned in a little bit on your signal. I don't know, maybe you lost me now. I was off a little bit. I could probably play around with the cat a little better, because I do sound kind of funny to myself right now, but I do understand, of course, is what I'm saying. So, yeah, fine business. It's beautiful.
Now we're going to try to find our own downlink.
Frequency on you, so...
We're busy today. Okay.
November 1 Hotel, Oscar, Quebec. November 1 Hotel, Oscar, Quebec. CQ VO52 from November 1 Hotel, Oscar, Quebec. November 1 Hotel, Oscar, Quebec. CQ VO52 from November 1 Hotel, Oscar, Quebec. Norway 1 Hotel, Oscar, Quebec.
And that you're hearing the downlink is actually in full duplex, so I'm hearing my uplink coming back down from the satellite.
CQ VO52 from November 1 Hotel, Oscar, Quebec. November 1 Hotel, Oscar, Quebec. QRZ, November 1 Hotel, Oscar, Quebec. CQ, November 1 Hotel, Oscar, Quebec.
All right, I'm going to look for somebody. This was a relatively low elevation pass. So I'm going to go look for somebody rather than keep calling.
12 CQVO 52. Victor Echo 3, November Papa Charlie. VE3NPC calling CQ and listening.
VE3NPC from N1HOQ.
Didn't quite get that. Oh boy, I don't know whether I'm going to get it or not. N1 something, VE3NPC, go ahead.
Roger, it's November 1 Hotel Oscar Quebec. November 1 Hotel Oscar Quebec, over.
Okay, N1HOQ, VE3NPC. Name here is Claire. Charlie, Lima, Alpha, Romeo Echo, and Foxtrot, November 25, over.
Yeah, Roger, Claire. Name here is Sean, Sierra Hotel Alpha Whiskey November. I know it's been a while, but we have worked before. And I'm in Foxtrot, November 4-1 on Cape Cod. Fox Nancy 4-1. You're 5x7, 57, Claire, over. Okay, Claire, getting a little light with me, getting a little light, but nice to work you again, Claire, and we'll hopefully see you again on the bird there. VE3 November Papa Charlie from November 1 Hotel Oscar, Quebec, 73, Claire.
We got a little light into the bird there. His uplink was a little weak, but we did make contact. And I've talked with Claire many times on the satellites. He's a regular. Victor Echo 3. This is Wyatt, AC0RA.
Alpha Charlie 0 Radio Alpha from November 1 Hotel Oscar, Quebec.
Yeah, N1HOQ, AC0RA. How come I haven't phoned for the long time since I've heard you on?
Yeah, I'm sorry. I think your name is Wyatt, if I remember correctly. What was the grid again?
Where'd you go? N1HOQ, AC0RA.
Yeah, Roger, N1HOQ, we're still here. The bird's getting a little low on us. Fox Nancy 4-1, Fox Nancy 4-1, over. Okay, the bird is just about down now. Elevation is 1.5 degrees, so we're pretty much into the trees over there at the edge of the ball field. So, but that was Wyatt, AC0RA. I've also worked him many times on different satellites, both FM, and this was a transponder bird. And most of the guys on there were using cat control. Sometimes we need to get lined up a little bit, but it works fairly well. That was only an 11-degree pass for us, so pretty short duration, pretty short window. But when the bird starts to get down below the tree line there, that's pretty much it. For a higher pass, we'd have a lot more time for chatting on there, maybe a few more contacts. But we did make 2 contacts on that limited pass with Claire, VE3NPC, and Wyatt, AC0RA. So not too bad.
I'm covering the display, Sean. Could you explain the 2 digital readouts there, which was uplink, downlink, and all?
On the radio, yes. On the bottom is the uplink frequency of 435. That's in the satellite subband, 435 megahertz. That's the frequency we transmit up to the bird or up to the satellite. And the downlink is here, 145.906. That's our downlink. There is a passband, so we have a range of probably 9.2, 9.3, 9.5 maybe, down through 145.90 for sideband. And just a little below 9 is 145.9 is where you might find a lot of CW action down there. That's this particular bird. Other birds have different frequencies, but a combination of these frequencies for uplink and downlink, they may be a few hundred kilohertz one way or the other.
Yeah, for those that don't know, the 910H, I saw both digital readouts changing together. What's that?
Okay. Yeah, unaided by my hand, the frequencies will change, and that is because the computer is controlling the uplink and downlink frequency. so that it corresponds with where I move to listen to tune someone in. The computer tells the radio the proper uplink frequency needed to match that frequency that I'm listening to on the satellite. So,
Why don't you explain
now,
the,
as
why don't
well,
you explain the Doppler
yeah,
effect?
as well as that, while I'm not touching the radio, you will see the display move top and bottom as well. And that is adjusting for the change in frequency caused by the Doppler effect as the satellite's flying over. And most of you know, if you ever listen to the train coming down the tracks and it goes by and the pitch changes as it passes by. It's generally the same effect going on with the satellite flying over at radio frequency. So the computer controlling the radio will make those changes for me so that I don't have to do that. However, if I didn't have the computer, I could do it manually with the radio. But it takes a little time to switch back and forth between the two bands to make those small adjustments, and certainly with the computer it makes it much easier. Most of the fellows on the transponder birds these days are using CAT control, or computer-aided tuning of their radios. So there you have it.
Speaking of batteries, we're about running low here, so we'll probably have to sum this up. I just wanted to thank you very much, John, for the demonstration.
My pleasure.
It was terrific. Thank you, W1 PJM, for stepping in and assisting us as well. This is W1AKN. Toodaloo for now.